Hi everyone, this is Mike with a video to explain some important ideas about hypothesis testing with two samples. And in addition to the main concept of the idea, I also want to show you some examples of how you can use Google Sheets in order to do these computations. I'm providing you with a preloaded Google Sheet actually that should be able to help you get a lot of this done, and I hope will be useful to you. So let's talk about some important things in general about hypothesis testing. So remember that hypothesis tests are for using sample statistics to test a claim about a population. Usually in scientific research, we're going to want to compare two groups of individuals. Up until now, our hypothesis tests and our confidence intervals have always been about single samples, but now we're going to extend that to two samples, and we're going to want to know whether or not there's a meaningful difference between them. So here are some questions that people might ask or that people have asked, and they are great examples of where we would want to compare two sample sets of data. So, are boys better at math and science than girls? Do people who get a new medical treatment have better health outcomes than those who get a placebo? Or maybe we want to know if plants are going to grow better using one kind of fertilizer over another. And there are probably plenty of other examples of this, and I imagine you can think of a few in your own field that you're interested in. So in those cases that we want to do a comparison, we can use a hypothesis test on two samples. So we're going to need to decide whether the two samples are independent or dependent. Dependent samples are often referred to as matched pairs. That usually is when you're testing the same thing or the same person twice or at two different times. Two samples might be independent if you collect them, say, from different populations, or if you randomize your choices for each sample. And in general, we're going to determine if we're going to compare two means, that would be mu1 minus mu2, or if we're going to compare two proportions. I think most of the examples in the assignment compare means rather than proportions, but a lot of this still works on proportions as well. And when we're talking about means, we're going to assume that we do not know sigma. That's generally the case when we're doing statistics, and so that means we're going to use a t-distribution for our calculations. And for purposes we haven't really discussed in the class, whenever you use proportions, we're going to use a normal distribution, but the spreadsheet that I'm going to show you takes all of that into account for you. So when we compare two samples, the null hypothesis is really always the claim that no difference is going to be present. So if there is no difference between the two means or proportions, then we consider them to be the same. If there's no difference, then that means they're the same. And so if they're the same, when we subtract them, the value of their subtraction of their difference will be 0. So the null hypothesis is going to involve the difference being 0, whether that's population means or proportion means. Or proportions. And so when we're computing with two means or two proportions, then the standard error is going to change. And the formulas that you may see in the textbook or in some other videos are given here as well. Again, you shouldn't need to worry too much about the formulas themselves because they're part of the spreadsheet that I'm going to show you in just a minute. The main process for comparing two samples and making a claim about two populations is the same as for testing with one sample, except that the calculations are different. So the process, though, is the same. We're still going to compute a test statistic based on the samples. We're still going to determine a p-value for that statistic, and then we're going to use the p-value in the same way that we did before to determine whether or not to accept or reject the null hypothesis. And the rest of this video really is going to be to show you a couple of examples of how to do that. So let's do that. The first thing you're going to want to do is locate the Google Sheet template in MyOpenMath. That'll be located in the Advanced Hypothesis Testing block in MyOpenMath. Then you should click on that Google Sheet and make a copy of it to your own Google Drive. So you're going to want to log into Google and then copy this document, because that will enable you to use it. The document that's linked there is only one that you can view, but if you make a copy of it and put it in your own Google account, then you should be able to mess around with it. And then I'll show you in these examples how to conduct the hypothesis test. So let's head off into MyOpenMath. So if you're here in Unit 3 in Inferential Statistics, you're going to want to go to this Advanced Hypothesis Testing folder. And the link will be appearing here very shortly. As I'm recording this video, the link is not actually currently available. So when you go to the link will take you here, and you'll see a page like this where it says View Only. And if you click on the View Only, it says you can only view this document. And if you want to make changes, it says you can ask the owner for access. You don't need to request access. I don't want you to edit this document. What I want you to do is make a copy of the document, and then you name it however you like, and you're going to put it into your drive. Okay? So make sure before you start any of this that you make a copy of the document. And I'm going to go ahead and copy it in there. Yes, I do want to make a copy. And then it will appear in my drive like this. Okay, now that I'm in this sheet, you'll notice that there are some directions down here at the bottom, some instructions. So notice it says it says make your own copy of this spreadsheet before you edit. Notice it says always start in cell A1, and then it has some other things you can use here as well, or things that you should pay attention to. Notice this spreadsheet also has some pre-filled things that you can use for confidence intervals and for finding descriptive statistics, as well as doing some things related to probability. These are simpler sheets, and you're welcome to use these in the future. But for now, I'm just going to show you this hypothesis testing sheet. And let's go to one of the problems in the assignment. We're actually going to start down here at number 17 in assignment 12. And here's a question where it asks about the average donations between two different religious denominations. Do Presbyterians donate more than Catholics in church? And so they collected data. They randomly selected 60 members of a Presbyterian church, and they found their average donation with a standard deviation. And they randomly selected 40 members in a Catholic church and found their average and their standard deviation. And so they ask us what we can conclude based on alpha being 0.10. And so we'll go through piece by piece here. There's my mouse. Okay. So because these are randomly selected samples from two different populations, this is going to be an independent two-sample test. And because we don't know the population standard deviation, we're going to choose a t-test. So we've got the t-test because we don't know the standard deviations, and because these are randomly selected, we're choosing we have two independent population means. So it's going to ask us about our null hypothesis. These are about means. So we're going to ask, are these means equal to one another? We're choosing mu instead of p because p stands for a proportion or a percentage. And the null hypothesis is going to be, now notice this question says, does the average Presbyterian donate more? So we're going to ask, does the Presbyterian, the alternative is that the Presbyterians donate less. I might otherwise choose greater than or equal to, because my null hypothesis is that they do donate more, but I always need to keep in mind that these two things are at least equal to one another. Okay, so those are my choices so far. Now I need to find the test statistic, and the test statistic again is going to be a t because I'm using the t-distribution. And I'm going to go into the Google Sheet to input the data. Okay, so here we are at the sheet, and we're going to enter in the data in this hypothesis test for two means, independent with statistics given. And remember, we had a mean of 27 among the Presbyterians with a standard deviation of 9 and a a sample size of 60. And then among Catholics, the mean was $23, the standard deviation was 7, and the sample size was 40. And notice we get these, this t value, this is our test statistic, and then we have these p values here. So we've got p is 2.4927, so I'm going to type that in here, 2.4927. Oops, sorry, not in the p value. I'm going to type that here in the t value. And then the p value, which is right-tailed. Remember, our alternative hypothesis is that the Presbyterians give more. Our p value is 0.01441. 0.01441. And because the p value is less than or equal to alpha, then that means we're going to reject the null hypothesis that these two things are equal to one another. So notice the results are statistically significant, so we're going to eliminate the first and the last options. These are statistically significant results. And remember what we were trying to conclude, or we were trying to find out. Do Presbyterians donate more on average than Catholics do? Well, this data suggests that the Presbyterian mean of 27 is actually bigger than 23. That's not just a random fluctuation. So those are statistically significant, and so the question is there sufficient evidence to conclude that the population mean amount of money is more than the population mean amount of money that Catholics donate? And the answer is yes. The difference here is that we don't need a hypothesis test in this third thing to say what happens here. So it says the mean donation for 60 Presbyterians was more than the mean donation for the 40 Catholics. Well, that's true regardless of whether we do the hypothesis test or not. This third option is just answering a question about the samples, and the samples show that Presbyterians, this sample of Presbyterians did donate more than the sample of Catholics. What we're trying to do is say something about the population means, and that's why this second one is the right answer. So we press submit just to check our work here. And notice we're correct everywhere but the p-value. Let's see, maybe did I go too many decimal places? Let's try that. No, and it didn't like that either. Well, let's find out which one it preferred. We were right everywhere but there. And we wanted to go, looks like they wanted us to be half of that size. Why would they want us to be half? Oh, this is the, oh, I chose the two-tail. That's why. So if I had chosen the right tail like we talked about, then that would have worked. And you probably caught that a few minutes ago when I said it and typed it in. But the right tail p-value is what we wanted there. And so that would have given us the correct answer to this problem. In the next video, I'm going to show you how to do a problem like number 10. And number 10 actually doesn't use statistics, it uses data. And we're going to look at how to apply that data in the same sheet that we were just looking at.